All right, for our next video, we're going to get the Laplace transform for the sine function. And it's actually really easy to use the cosine results to derive it. What we're going to do is go through and just use the other Euler property. So instead of cosine, we'll have sine. And that's actually the difference with the division by 2i. So the Laplace transform of the sine of bt is just the difference of those two exponentials divided by 2i. So when we go through and actually do this calculation, you notice that all we have to do is now divide by 2i, and we're now subtracting in place of addition. So we have 2i and 2i, and when you subtract again, at this step, we have 2i, and then you'll notice here that we're going to have a subtraction here, but now this is going to turn into an addition. And when you do that, instead of having the i's cancel, it's actually the s's that cancel. So now the s's are going to cancel, and we're going to have the ib's doubling up on you. So what you're going to see is still that division by 2i, but now we're going to have 2ib upstairs in your numerator. And when you go ahead and replace the s with that, you will notice now that both the 2i's are going to cancel out. And again, that s is no longer there. It's going to be b. So it turns out that the Laplace transform of the sine of bt is just b over s squared plus b squared. And it's, again, really easy to get that Laplace transform for the sine function off of the cosine function.